Good afternoon, welcome. Hello to a further practical learning session with the topic KNX DALI Gateway Premium. With a new ETS application version 2.0, and here are the two functions: operating, duration, and the new features in the ABB IBAS tool. My name is Thorsten Reibel from the Competence Center Europe Smart Buildings. Yeah, this session takes around 40 minutes. I hand over directly to Jürgen. He will present.
Hello and welcome to this practical learning session. My name is Jürgen Schilder. Today I will show you the special function operating duration of the ABB IBAS KNX DALI Gateway DGS Sx.64.5.1 Premium with the new application program 2.0 and the enhancements in the ABB IBAS tool. After an introduction to the operating duration function, I show you the parameterization in the ETS and then live the function in operation. The focus is as always on a live demonstration, and I'm only showing you some slides at the beginning. I would like to start with an overview of our KNX DALI gateways and DALI light controller. On the left side you can see the DALI gateway DGS81, a broadcast device, then the two DALI light controller, DLRS and DLIA as a D-Ray component and surface mounted devices. Then we come to our two DALI gateway basics, DGS1.64.1.1 and DGS2.64.1.1. Differences here only the number of the outputs, only one output and two outputs. Both DALI gateways can control the signal or also groups and emergency converters according to the device type 1. So the next two DALI gateways are the DALI gateways Premium, DGS1.64.5.1 or DGS2.64.5.1. So the 5 means these are premium devices. They have the same functions like the basic, so we can use it for signal control or group control and also emergency converter, plus some functions like color temperature control between warm and cold white. So, and last month we launched a new update, and with the new update we can have here extended functions. So both devices, you can here see the basic functions can now update it with the new application version 2.0 and offers now more. Also the support of device type 8's color control, RGB, white and also HSV. So we have additionally 4 independent sequences per DALI output, the load shedding functions, and the topics of today are the operating duration per ballast group and the enhancement in the IBAS tool. We have given numerous webinars and online sessions about all our DALI gateways and also the last week special about this new software application 2.0. You can find all these recordings and the slides in our training and qualification database. What is now also new, that existing device with the software version 1.0 can be updated via our ETS app, and the complete parameterization and the group addresses can be taken over. This is also part of one of our webinars we have given last week. So then we come to our function 1 of today, the so-called operating duration function. So what does it mean? The operating duration function determines how long a group or a ballast remains switched on. So we get here in hours or in seconds, it depends on the parameter settings, the operating duration. We don't say hours because we get here also the values in seconds. That's why we say here operating duration. So with this value, we can identify and we can also plan timely maintenance for a lamp change. Like in some public buildings, the lamps must be changed every 1,000 or 10,000 operating hours. If you have fluorescence lamps, also other types like LEDs, over the time the lamps lose their luminosity and then they have to be replaced. And with this new function, we can determine the operating duration and then we can also trigger an alarm message by using a 1-bit information. This will show you later the parameterization. But very important, we must know this operating hours, this function from our ballast. So according to the DALI standard, the operating counter function of a DALI ballast is not mandatory. There are maybe some ballasts on the market, they support this function, but it's not mandatory. And so a wide range of ballasts, they don't support this function to count the operating hours. So that's why we use the following solution in our DALI gateways. Now we count the operating duration when a group or ballast is considered to be switched on. What does it mean? If the brightness value of a ballast or group is greater than 0%, then it must be switched on between 1 and 100%, and there is no lamp or ballast fault. Yeah, and then we are sure that the lamp is really on, and then we count this operation duration in our DALI gateway. This is a solution we can offer. The problem is not the DALI gateway, the problem is here the ballast. That the ballast does not support, or many ballast does not support this function. So we can solve it in our DALI gateway. So, and then we can get this operating duration per group and also per ballast as a in hours. The value can be in hours or also in seconds. So including this alarm function when we exceed a threshold, like our threshold of 10,000 hours. So another possibility is to use a so-called at-rest group object. So then we have only one group object for the complete output, and in this group object we have the number of the ballast or the group and also the operating duration. But when we use this at rest, then we have no alarm function and we have also no values in second. So when you have a visualization, then it's quite popular to use this at rest one. Then you have only one group address for all 64 ballast or 16 groups per output. Or you can use, of course, both of them. And later I'll show you both of these solutions. So, and then depending on the parameter settings, according to the data point type, you get the operating duration in hours or seconds. What do you want? And also when you have a group, and in a group you have more than one of the ballast, and the operating time of a group is defined of the ballast with the most operating time. So if you have maybe 10 ballast, and one ballast has maybe 500 operating hours and the other one less than 500, then the operating time of this group is now the most, which is here our 500 hours. So, and internally we have here a logging rate of 5 minutes of the operating time. So, and the hour format is given as fully hours only. So, for example, when we count here from the beginning, 25 minutes, then we get on the KNX bus as our operating duration only 0 hours. Or when we have 1 hour 55, then we have 1 hour. So every full hour is now counted in the DALI gateway. So, and when we use the seconds format, the seconds format is based also here on our logging rate of 5 minutes. So then we get here the value as a multiple of 300 seconds, because 5 minutes multiplied 60 seconds, then we have here 300 seconds. Good, then let's come to the first exercise we want to do. We have here a ballast, my ballast number 3, and we want to read and write the operating duration of this single ballast. So then we enable the parameters, and then we get here object of this ballast number 3. You see output A, ballast number 3. According to the parameter settings, I use here data point type 7007007, which are hours as 2 byte, and I got here another object with the alarm message. So when we exceed our threshold, then this value of the object is number 1. So it's the first we want to do, to read and write the operating duration per group or per ballast. Then we use this object. So then the next exercise is we want to use this at rest function. So then you will see we get here object for the complete output, read operating duration, and another object for writing operating. So these are here 3 byte objects. And in the 3 byte objects, we must have the information, the operating hours. This is a 2 byte information. And in the other byte, we have the information if it's, for example, a group or a ballast, and the address of the group and the ballast. So in this case, maybe you need a visualization or another tool, for example, to send here or to create this special 3 byte group telegram. Of course, it is quite easier to use also here the ABB IBUS tool, or you send this telegram via the ETS, which I show you also in the next step. Good, then we come to this 3 byte object, this so-called address. So now we have it's 3 byte, and if we want to read out the value of my ballast number 3, we have exactly to write a telegram with this value 000082. This is in hex, or in decimal, you see here 00130. So now what's the meaning, or how is the structure of this byte? So we have here the beginning, the high byte, the middle byte, and the low byte. And the high byte and the middle byte, we have the operating hours. But at the moment, when we want to read out, we have to send a request. So then these 2 bytes are not evaluated. So for us, it's now important to have a look here on this low byte, because in the low byte, we have at first the information that we want to read out the value, a so-called a request. And then this first bit here, or let me say the bit number 7, because we read it here from left to right, bit number 7, bit number 0. The first bit here, bit number 7, must have the value number 1. And then the DALI gateway knows, okay, this is a request, and the DALI gateway will now then respond. Okay, bit number 7 must be 1. The next bit, the bit number 6, we give the information if it's now a group or a ballast, individual ballast. In our case, I want to read a value of a ballast, and then this bit must have here the value 0. If you want to read out a group, then the value must be 1. Okay, so we have the first bit, the second bit, and the other 6 bits. Bit number 5 to 0 describes the number of the ballast or of the group. So in here, we are on the bit level. So what does it mean? That we have here values between 0 and 63. But in our KNX world or DALI world, we think from value 1 to 64 or 1 to 60. So what we have to do, we have to reduce here the value, ballast number 3, minus 1, and send here the value number 2. This is very important because here we start from 0 to 63 or 0 to 50. Okay, I want to read a value of ballast number 3 in our KNX world, so I have to reduce it by 1, which means 2, and then the bit number 0 and must be 0, and the bit number 1 must be 1. So exactly, we have to send this structure here 1 0 0 0 0 1 0 in our low byte, and this means when you convert it into hex, exactly 82. So later we have to send exactly the value 0082, and then we get here the next step as a result sent by the gateway with the value. So the gateway knows, okay, the first bit was a 1, then he will respond again with the same group address. And then we have the bit number 7, now the information that it is an answer. The bit number 7 here is 0. The next bit is the same like before, 0, which gives us the information. This is a ballast. And here we have the address of the ballast. So this is exactly the principle. At first to send a 3 byte with the information that is a request. It is a ballast, the number of the ballast, and then the gateway responds with an answer with the information that is another answer, that's a ballast, and in the high byte and the middle byte we have our operating hours in hex, and then you have to convert it into decimal. That's what we're doing in the next step. Good, and then we want to write also a value operating hours into a ballast address, like here for example in my group number 4, I want to write new operating hours via my visualization or via the ETS. So then I have to use here the other group object. The group object is also a 3 byte, and in the high byte and the middle byte we have to enter here our operating hours. Like for example here we want to write 2473 hours, then we must convert these hours into the hex format, which is exactly 0985, and in our low byte we have to use exactly this structure here. That is that we have here in the bit number 7 a value 1, which is a write command. So DALI gateway knows, okay, I have to write this value, new value, into my operating duration counter. The second bit must now a 1, because the following numbers here is now a group, and here in the bit number 5 to 0 we have to enter here the name of the group. And remember, here we have a range between 0 and 15. And in our KNX world, we think about 1 to 16, so we have to reduce here the value from group number 4 to group number 3, and 3 means here the bit number 0, bit number 1 must be 1, 1. So then we have exactly to send to the DALI gateway this value 0985 C3, and then the DALI gateway receives a new operating duration of 2437 hours. That's what we are doing now live. I have now prepared an ETS project, and I start now with setting the parameters. These are here. This is a device with all default parameters. I activate this button here, highlight changes, and then when I change a parameter, you see this parameter is now highlighted yellow, and then you can following my parameter settings. Good, then let's start with my output number A. You see at default, group control is activated. I use also individual control because I want to read out the operating duration of my ballast number 3. I have to enable it yes, and I have also an emergency converter here in my training board. Good, and then we go to the output A. The output A and the sub-menu functions. We have here a parameter where we can now enable our operating duration at rest. So here we have enable group objects, read operating duration at rest, and write operating at rest. So now when I say yes, I want to use this at rest function. So then, we lost some seconds. No. Okay. So, and then when we have a look on the group objects, we will see here the object number 54 and 55. You see here read operating duration, a 3-byte, and write operating duration. Okay, so and then we want to use additionally the to write and to read the operating duration of a group or of a ballast. So then we go here to our groups. So I enable only, for example, group number 4. So then I get less objects, which makes maybe the parameterization here easier. Oops, what happens with my ETS? So I say no other groups. Then we get less group objects, less parameters, no other groups. Okay, so then my group number 4, I can enter, for example, here name. I use a friendly name, like here, this is my LED white, is my white LED strip. Additional function, no color temperature, it's device type 6, only light on, no color, no nothing. And I can go here to my parameters and sub-functions to the functions. So I can make all the settings per group or per ballast, or I can use it here also in a template. But in this exercise, I want to make it individually. I say no template, and then I get here exactly the parameters of my group number 4. If I want to use here also the addressing per device, then I can say yes. Yeah, and then I get also here the 1-bit objects. But now of my group number 4, I want to use only the addressed one. So then we come to our ballast. I enable now my ballast number 1, 2, 3. And go here to my ballast and enter, for example, here user-friendly name. This is my LED strip left of my training board, and this is a RGBW. So I select here only as a parameter RGBW. And all parameters we have explained in our last online training. So go to our training qualification database, and then you can see here all of the steps you have to do to parameterize here the RGB control. The only thing we have to do, we go here to our so-called functions, and in the function we enable now the operating duration per this ballast, and then we can read out via group object exactly the operating duration of this ballast number 1. So we say yes, and then we can select here, or we can define the data type. It is, for example, data point type 13100. It's in second. Yes, I want to have this one in second. Then I select this parameter. And if I want to have the alarm function, so I can say yes, and here I enter my threshold. So then, if the operating duration exceeds this threshold of 10,000, we get another group we get the information on the group object alarm, and it's sent after change or on request. So when we keep here after change, and then the object sends here command value 1, and we can trigger it, for example, on our panel or the control touch, then we get a push notification with the information that we have now to replace the lamp of ballast number 1. Good, that's all we have to do here. And then we go to the second ballast. Second ballast, I write here also a name. This is my LED strip in the middle. No color temperature, nothing. And I go here again to the submenu functions, and in the functions I say here individually, and the parameter enable function operating duration, I say yes. And my device ballast number 2, I want to have the values as a data point type 12, or according to the data point type 12102, 4-byte in hours. And then I get the operating hours here in this format. And if I want the alarm function, I say, of course, yes, 10,000 or 15,000, 20,000. Maximum value are here 65,535 hours. So, and last but not least, ballast number 3. So here again, user-friendly name. And this name is also downloaded in the DALI gateway. And later via the IBUS tool, we can read out here exactly this text here. LED right, and this is temperature color. So I use here the color control, temperature, yes, it fits. Then I go here again to the functions and say, yes, I want to use also the operating duration of this ballast number 3. And the last parameter here, you see data point type 70007. It's a 2 byte in hours. So now we have all 3 possibilities. Ballast number 1 in seconds, ballast number 2 in hours, 4 byte, and ballast number 3 in hours as a 2 byte. So these are the 3 possibilities. We get our operating duration. Good, so far. When we have a look on our objects, then you will see here my ballast number 1. We see the operating duration in seconds, data point type 13100, device type DALI ballast number 2. You see here in 4 byte as hours, and here my ballast number 3, 2 byte in hours. So these are the possibility. The next step is we have to link our group addresses and download the devices. So I have already linked the group addresses. I have made a download, and I show you now all the settings here on this DALI gateway, which is still downloaded and in operation. Okay, so further let's do diagnostic and read out here exactly the values. I clear now the recording and start with the first exercise. The first exercise is exactly here to read out the operating duration of my ballast number 3 by using exactly this group object ballast number 3. So I have now to read out the value. Okay, so I have to enter here then my group address, and the group address of my ballast number 3 is 2/6/137. You see, it shows me exactly the correct data point type of my ballast number 3, data point type 7007, and then I click here on the button read, and then you see here the read command sent by the ATS via the IP router tunnel 1, and here I get the answer group value response from the DALI gateway with the information of my group address, same group address, ballast number 3, and here in hex 0DFC I get now the operating hours. Yeah, what is 0DFC? Yeah, no worries. We start our calculator, and in the calculator we switch here to hex, and then we use here 0DFC, 0DFC, and then we see exactly, these are 3,580 hours. Or you see here also in a decimal value, the group monitor shows you also the value here in hours, 3,580 hours. Or if you want to read out the same, also the ballast number 1, ballast number 1, it's the address 170. Remember, then you will get here the values in seconds, because I set here exactly data point type 13100, then I get here the values as a multiple of 300 seconds, because you know we have here the timer of 5 minutes base. Good. Or for example, ballast number 2, read, and then we get the answer here. You see 279 hours in a format of 4 byte. So depending what you prefer, 2 byte seconds or 4 byte, you have to set the parameters. Now it's also possible to write here operating hours to a single ballast. So then I have to enter here the group address. This is my DALI ballast number 3. Before, you remember, 3,580, and I can send now here a value, for example, 0. After lamp change, I send here the value right, and I read again, and then you will see here the answer, value response, the new value 0. Or you can set not only 0, you can set also here a value or write a value of 7,268. Why not? Yeah, you can write here the value, and when you click on the value read, then you see the response. Now the operating duration of my ballast number 3 is now written to 7,268 hours. Also possible. Good. This is the function when we use it per ballast or per group. And the other one is that we use it not only per group, or per ballast, that we do it at rest. At rest means, remember, we have a 3-byte group object. Group in the high byte and the middle byte, we have the hours, and the low byte, we have the information, if it's a request, if it's an answer, and the information group or ballast and the address. Okay, then let's clear here. Clear. So then I want to read here of my device, of my ballast number 3. I want to read out here the operating duration. Then I have to send exactly a group address with the value 00082. The middle, the high byte are not evaluated because at first I have to send the request as a write information and then the gateway response. Okay, so I use here the group address. The group address of my addressed bytes is 235. Yes, it's exactly 235. And as a default, the group monitor thinks, oh, 3-byte, this is a data point type time, because this is the only format, data point type time for 3-byte, but we say, no, you are not a time. Yeah, you are here universal 3-byte data point type, so we change it here to 3-byte. And then here we have to enter exactly our 00082 in hex, or you can use it also in decimal, between 0 and 255, but it's easier to use here the hex. And then I have to enter here the value 82. And remember, 82 means the first bit, bit number 7 is 1. Then the DALI gateway knows this is a request. The next bit, bit number 6 is 0. The information that it's an individual device. And in the bits number 5 to 0, we have the address of our ballast, which is the address number 2. But in our real world, it's number 3. Remember, all addresses are here shifted by 1. Okay, so and then I click here on the button and send here this value. And then you will see there's the response now from the DALI gateway, the same group address. And you see here the information 1C6402. So this is now the response. High byte, middle byte, low byte. So and then we have to do some diagnostic. So one is some diagnostic. You see exactly the 1C6402. Remember, in the high byte and the middle byte, we have our operating hours. So we have to take the 1C64 and convert it into decimal. So we use again here our calculator, which we set it here hex format. And then we can enter here 1C64. And then we see exactly here 7,268 hours. And then in the next byte, in the low byte 02, we have exactly the information here. The bit number 7 is the information that it is an answer. The second bit is also 0. Bit number 6, then we know, okay, it is a device, not a group. And in the bit 5 to 0, we have our address. 02 means in binary exactly this one. And remember, all values must be shifted by 1, and then we get here the value in our KNX world, which is our ballast number 3. Because here in our KNX world, we think from device 1 to 64, and here on the bit level, we have a range from 0 to 63. So exactly what we expect by sending here a request and then the answer of the DALI gateway by using here this address function. Good, and the next step, what we want to do, is, for example, to write the operating duration to the group number 4 via this address. Okay, so then we have to do the same. So we have to send now via this group object write operating duration here a value of 2,437 hours. So we have to convert this value from decimal into hex, which is exactly 0985 by using our Windows calculator. And in the low byte, we have to set here in the bit number 7 a value 1, which is a write command. The bit number 6, we have to set it also to 1 to give the information now a group. It's information for a group. And in the bit 5 to 0, here we have to enter the value 3, which is here the bit 1, and the bit 0 must be 1, 1. Because we want to send this value to our group number 4, but the same here in our bit level, we talk about 0 to 15 plus 1 equals here on our KNX world to the group number 4. Okay, then let's do it. At first, I want to read out here exactly the value of my group number 4. So I have to enter here my C3. This is exactly here my group number 4. So I send here command, and then he responds. At the moment I have here about 04 E6. This is my operating hours I have now. I want to change it, so then I have here to send exactly this bit structure 09 followed by 85 and my C3. So this command here, click on the button, and I have to use the group object, the next one, the group object here, to write the information and write this information to my DALI gateway. So then the DALI gateway accepts this new value, the 2470 hours in the group number 4. Good, okay, so far this explanation here of the operating duration, to use it individual, per group, per ballast, or to use it at rest, or both as a combination. Good, then we continue with the IBAS tool. We have also some enhancements in the IBAS tool, and I share now here my camera review and the ABB IBAS tool. So then let's start with the new maybe enhancement, the ABB IBAS tool. The latest version here is 1.9.45.0. When you start the IBAS tool, there's a button, and when you're online, then you see that there's no update available. You can use it here as in a light or also in a dark view. I prefer to use here the light view. So then we start here at the beginning, our page general. You see as an overview how many devices are connected to the output, how many devices are monitored, the brightness level selected. Now here, this is new, brightness level unselected. Default, it is 0%, 1% or 5%, but now it's a parameter which is here unchanged. Unchanged means, later when I go back, or when I go here to my second page, I select here device, like my device number 1, for example, or my device here number 6, the device number 9. You can exactly see that the other devices, the value is now unchanged. Before we had here only a parameter, maybe 1% or 0. Let me select here this parameter, click here on the button apply, and when I go now back and I click here again on my device number 10, you see the difference. 10 goes on, and all 63 other devices goes here to this value we have set here unselected, 0%. The advantage of this new parameter unchanged is if you have a running project and you have to replace a ballast, or you want to do some tests or maintenance, and then the other ballasts are not affected. So when you have an open office, for example, the people in the room, they have no influence by the light, because all other lights remains in their actual position. Okay, good. This is one, I think, very nice parameter to say here unchanged. And if you do some changes, you have to click here on the button apply. So new feature here for the emergency lighting converter, like I have here one, and you see here this, with the battery, the converter here. You see here, this is the converter with the battery connected to the mains, and here we have the spot with the functionality. So I can identify now, or when I select emergency converter, he will respond with a so-called identification. The identification depends on the manufacturer. It can be beep, 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 or the LED can flash, or the LED can go on or off. So this is open to the manufacturer. But if it's only a beep and you are in an open office and there's noise in the background, you cannot identify which converter is it. And now we have here the function that we with the parameter do a function test. So when I apply here, and then I go here to my DALI overview, and I click now here on my emergency converter, then he starts with a function test. You see the light here goes on, and it's doing exactly this typical function test. And then you can see, okay, this is the emergency converter in this corner over there, at the end of my room. So you can make it easier to identify which converter has the address number 25. Good, okay, then let's, DALI. So then let's go here again to my main menu. What else? The fade time, or you can also select a device as switched. You can use it also as blinking. So when you say blinking, you can enter here the cycle. And then, for example, when I click here on my ballast number 1, now, sorry, I missed to press the button apply. please, when you make some changes, click on apply. Go here again to my ballast number 1, and then you see ballast number 1 here exactly is blinking. So it's also maybe easier for a visual detection which device is number 1. Good. Okay, then let's change it here to switching. If you enter here fade time, then it's dimming darker or brighter. Good. So far the information. What else? Here we have also overview. How many % of our communication objects are used now at the moment. I have linked, I don't know how many hundreds of group addresses, but at the moment I used only 2.3%. So see the status. Good, then let's go here to the main page of DALI. Here you get an overview of all your 64 ballast, 16 groups. You can link here also devices into the groups. And here we have also a new feature. For example, one is the broadcast converter identification. So when you click on this button, the DALI gateway sends a command to all emergency converter on the output A, and then they start with blinking or beep or so on. It's a broadcast information to all converter, and then you can test if all your converters are now connected to the mains, connected to DALI. So the first check if everything is okay. So I click here now on start, and then you see here all converters, like my only converter, if the address number 25, now starts here flashing. So you can test all the converter, identify if the wiring is okay, and so on. Good, this is this parameter. So what else? So I zoom here, you can see what is now new, that we have here a small square in this field. You see here, here, and here. And by clicking on this square, we activate the called monitoring function. Before, when you have done all the settings of the DALI devices, you have here to press on the button, trigger DALI device monitoring, and then this function was active for all ballasts, all 64 here on the output A. And here you can do it step by step. So when you tick here this field, so do it here, what happens? You see the field is ticked, and now only this device number 1 is now monitored. Okay, so we can test the device, everything here is fine. Oops, so. And switch on is my number 1. And then you can go to device number 2. Yes, it's the other light strip. You tick again here, and this device is again also monitored. And after a few seconds, you will see here the eye, and so on. So if our address is not correct, via drag and drop, you can, for example, change. At the moment, the red one has address number 4, and the green has address number 5. Via drag and drop, you can change the addresses. And now my device number 4 is the green one, and number 5 is the red one. Number 4 is the green one, and come on. Number 5 should come red. Oops. This is this one. Number 4. Okay, sorry, I know the problem. I have to say here 0%, because at the moment I have red and green and blue. This equals white. This is why I get here exactly not a pure red color. Okay, again. So here you see number 4 is green and number 5 here is red. So sometimes it makes sense to say no change, to say 0%. If you use, for example, here RGB colors. Good. Okay. And now when you tick here this address again, and you tick at the something here with my mouse, just a second. So, and I want to change then this address by drag and drop. You see here, drag and drop, you get the information, not possible. Because if a device is monitored, you cannot change the address. This helps you also, for example, to prevent the mistake. Because today, you do the settings of this ballast 1, 2, and 4. And tomorrow, if you want to continue and you want to do a change the address, by chance, nothing happens because this device here is fixed to the address number 4. Only if you untick it, then of course you can change the address. And at the end, you get here overview, and you see at the moment I have now 3 devices are now monitored on my output. So I know, okay, today I did the commissioning for 3 devices, and tomorrow I have to do it for the next 13 devices. It helps you also for kind of reporting. Good, then we come to the overview. Overview gives us here the information of all our devices. You see here the text of the group we have entered in the ETS, like here, for example, group number 1, LED red, green, blue, white, and so on. The name of my individual ballast, LED strip left, RGBW, and so on. So all names of individual control ballast, and these are here devices without names, because this ballast are here 4 to 15, they are not individually controlled, they are linked to a group. That's why when you say linked to a group, you cannot enter text. So, but now what is strange, that here my emergency converter appears. You see here the device type. Device type 1 means it's a self-contained emergency converter. Yeah, this is a special emergency converter, a so-called switchable maintained converter. This is a converter which can be also switched on and off by a command. And then he appears here also in the list like an individual ballast. So it's also possible to switch here on and off this ballast. Here you see some more information of my ballast number 1. He gives two informations. I'm a device type 6 and 8. What does it mean? It's a multiple device type, so he works according to device type 8, RGBW color control, and he can also understand device type 6, the LED commands. Or here, this is my typical LED, device type 6, and this here, ballast number 3, this means device type 8, this is for color control. And here in the overview, you get also some information. You can also switch some lights here on, for example. Yeah, this one, or switch off and such things. This is also possible. Good, then let's go here to the detail. And the detail view, I can select here at first my group number 1, and then group number 1, my device address number 1. I get here the information of my ballast number 1, which is my LED strip here. I switch now the light on to see, yes, it's my number 1. I can see here the color. At the moment, it's the color red. You see here the information in hex. It's a 4-byte value. The first byte here, DV means red. Then we have green, blue, and 00. This is the white value. So what we also can see is here the operating hours. You see the 3,580 hours. And if you want, you can change here also the operating hours via the IBUS tool. Of course, this is easier than via the group monitor when you use here the IBUS tool. Let me say, for example, if you want to enter here a new value, you click on the button, and then you can override the operating duration counter of ballast number 1. So here on the right side, you can change the color if you want. Via the slider here, you can change here, for example, to green, or here darker and so on, or you use here these sliders. If you use here HSV or RGB, you are absolutely free, and then you can see here the color, and you see here also the feedback in hex. So more information are here. Device supported color types. You see here the color type temperature control is not supported of the ballast, because it's a RGBW. And how many channels? 4, because I have on the output red, green, blue, and white. And also no device type here of XY coordinates. Good, so far. And a nice parameter is here also color enabled. Yes, that's my ETS settings. And the ETS, I have set a parameter that I activate the color control RGBW, and here the runtime, this information is read out by the ballast and gives the feedback of the ballast. The ballast said, yes, I'm really RGBW. Gives me also here the correct answer. Good, then we come at the end to our emergency converter. I have here one emergency converter. This is here the device with the address number 25. You can see here with one view the battery capacity or the charging level. Charging level is better, nearly 100%. And here we can trigger a different test, function test, duration test, partial test, and then we get a result. For example, if we trigger now the function test, start, then you see here function test is now started, and the test at the beginning he was pending, now he's running, and then after some seconds we get here the result. So far the enhancements in the ABB IBUS tool, and I go back now to my presentation. Then we come to the final slides as always. Our comprehensive documentation, the new application program, product manual, technical data, IBUS tool are available on our website. So go to abb.com/knx, and then you can go to products and downloads, like control, DALI gateway, and there you will find all this information. And in the ETS shop, online shop, there's also this ETS app, update, copy and convert. And with this tool, you can convert the DALI gateway, which is still installed, parameterized, link group addresses, and we can also use this tool to update the device, and at the end all the parameter setting and group address linking are remaining. Good, then we have something new for you. It's a so-called software repository. What is it? It is an Excel sheet which can be also downloaded from our website. And if you are searching for an old application, you will find it there. So this is here a screenshot of the Excel sheet. You click on the button search, and then you can enter here maybe the device type like DALI gateway DGS11, or also old device. And then on the left side, you will see here the current software versions of the ETS application. For example, the firmware, the link to the IBUS tool. And on the right side, you get the obsolete software version, like for example, ETS software application 1011 and so on. This is sometimes needed when you want to reconstruct your ETS project by using this ETS app reconstruction. Then you need exactly this version of ETS application which is in DALI gateway, also in the ETS. And then you can go there and you will find there all obsolete or historical software versions of the device. Additionally, there's also the link to the DALI gateway. You see here the order number and so on, and the release notes of the software. Good, training material available as always on our training qualification database and on YouTube in our channel ABB Home and Building Automation. There we can find also this video. And today you will get also a feedback email with this presentation, and maybe on next week Monday you get a complete feedback email with the link to the video recording and also the presentation slides. Yeah, then my last slide for today, it's vacation time, and we are taking also a summer break. In September, of course, we will continue with the online training. So I would like to say thank you for your participating and hope to see you again in September. Enjoy your summer break and stay healthy, and goodbye.